Welcome back to this YouTube channel. Today we'll continue our teaching series number-based system, and we are fixed with this question. We are asked to convert 3b9 base 12 to base 10. Now we can see that this question is a little bit different from those that we've been solving in our previous videos. This particular question has an alphabet here, which is B. Now in number-based system, A represents 10. Alright, and B represents 11, C represents 12, and so on. The reason for this representation is because we can't afford to write 11 here. If we write 11 here, it means we have 2 extra digits instead of having just 1 digit. Do you understand? So we can't afford to write 11 here. Rather, I would write B to represent 11, meaning we are talking about just one value. That being said, just bear in mind that A represents 10, B represents 11, C represents 12, and it follows in that order. Alright, so let's solve this solution. We have 3b9 base 12 equals, remember we said we have to assign indices to each of these digits here. We assign 0 to this and 1 to this because the values are assigned in ascending order. Here would have 2. Okay, so now we expound. The first digit is 3. We multiply by the base, which is 12. Then we raise it to the power here, which is 2. We do the same for the second digit. The second digit is B, which you can write 11. You can write B or 11 times 12, which is the base, raised to the power here, 1. Alright, then the next one we have 9 times 12 raised to the power of 0. Okay, so we have 3 times 12 raised to the power 2 is 144. Alright, plus B times, B is 11, so let's just write 11. 11 times 12 raised to the power 1 is still 12, plus 9 times 12 raised to the power 0. Anything raised to the power 0 is 1. Alright, so 3 times 144. 3 times 4, 12. We have 2. We pick 1. 3 times 4, 12, 13. Then this is what we get when we multiply 144 by 3. Plus 11 times 12. 11 times 12 should give us 132. That should be that. Then 9 times 1 should give us 9. Alright, so the next thing we do is to sum all of this up. We have 432, we have 132, and we have 9. Alright, this is 13, this is 7, and this is 5. So our answer is 573 base 10. Alright, that brings us to the end of this question. We've been able to convert this value to base 10. Don't make the mistake of writing 11 here. If you write 11 here, what happens is that you would have 4 digits, which is 3119 base 12. If you do this, if you write 11 in place of B, you will have 4 digits. And instead of having an exponent of 2 here, you would have exponent of 3. And that ruins the answer. You would have a different answer entirely. So that is the reason we usually represent 2-digit values like 10, 11, 12 by different alphabets.